Hello everyone, welcome to this session. In this session, we are going to discuss about implementation of the data types and the variable, which we discussed in the previous session. Here, we are going to implement some of the example of the variable creation, casting of the variables, rules which we discussed in the previous session. Let me create a Java project for this. I'm giving a name for this project as data type and variable. Let's create a Java class here to demonstrate different type of primitive variables and their rules. So we'll create here variable data type or variable intro. Let's say variable intro. Let's have a main method inside this. Okay. Here we are going to create a primitive type of variables. So there are primitive data type and non-primitive data types. In this session, we are going to only discuss about a primitive data type. So there are total 8 type of primitive data types, and we can store a values inside that using that those primitive data type by using a variable. So let's create a variable. I wanted to store 10 values, let's say, and we are going to store it into a byte type of variable. So first I'm creating here variable a, which is of type byte, and this is just a declaration of the variable. So we are declaring a variable here. This variable will be initialized with the value like this. So this is the initialization of the variable. So declaration and initialization are the two steps for the variable creation. You can combine these both of the step as a single line like this. So I'm creating another variable here, short b, and I'm declaring and initializing it on the same line. So declaration and initialization can be happen on the same line. Then the third variable here is a integer type of variable. Then let's create a long type of variable here. For a long type of variable, you can use a suffix here L, capital L or small l. It's not mandatory for a smaller values, but if you exceed the max length of the integer, then in that case it is mandatory to use a capital L or small l as a suffix. Let's try this. So suppose if I'm providing this value inside a long variable, then here we start getting an error. This error is because you have to provide a suffix here, and once you provide a suffix, this error will go away. So you have to remember here is if you are exceeding a long value to the maximum length of the integer, then you have to use this suffix, which is mandatory. Then next value is float type of value. So let me create a float type of value. For float type of value, if you create a float value without a suffix, then it will always give you an error. It is mandatory to provide a suffix f or small f or capital F for a float type of value. Else you will get a compile time error. For double type of variable, it's not mandatory to have a suffix at the end. Let me change the value. Okay. So you can provide here capital D or small d as a suffix, which is not mandatory. Then the next variable is char. In a char variable, you can store a single alphabet and the value must be in a single quote. Along with the alphabet, you can store a symbol as well, or you can store a numeric value also. If I want to store a numeric value, then there are some rules. Let's discuss about those as well. So I'm storing here value 65. Whenever you store a numeric value inside character, the value must be a positive value and must be a non-decimal value. If I try to store a negative value here, it will give me a compile time error. As well as if I try to store a decimal value, again it will be a compile time error. While storing a value inside a character or integer type of value inside a character, you have to make sure that value must be a positive value and it must be non-decimal. This is about character. And the last data type is Boolean. In the Boolean, you can store a true or false value. So let's say I'm storing here true value. So these are the primitive data types, and there are few rules to store a primitive data type which we discuss here. Let's print the values of these variables. So these variables you can further use for a mathematical expression, for calculation, generating results, displaying the results. So here we are using this to display a value on the console. So let me print the value of all the variables. And the last one which we are going to print is J, which is a Boolean type of variable. So here we are printing a value for each and every variable. Let's run this, and few things we have to observe in the output. The first thing you have to observe here is the suffix which we provided for a long, float, and double are not getting printed as an output. So it's for the internal understanding for a Java. That suffix we have to maintain or provide. The other thing is, if you see a I variable here, we are storing a 65 decimal number. This is the decimal value which we are storing. Decimal means numeric decimal type of value we are storing here. But while representing or while printing this value as an output, it's printed a character. So for a 65, we have a capital A. If I'm providing a, let's say, 97 value, then it will be a small a, and it will print a small a here. So even though you are storing a numeric type of value, the value will be represented as a character. When you use this in a calculation, if you are using for any specific calculation, then it will consider as a numeric. But when you are printing this value as an output, it will be printed as a character. So this is all about declaration, initialization of the variable, different type of variables creation. Then we discuss about few rules and we see in the output. In the next program, we'll discuss about the casting. Sometime you may have to change a data type or convert your value from one data type to another, and there will require a casting. In Java, there are two types of casting: primitive casting, implicit casting, and explicit casting. We'll demonstrate here in this program. So let me create primitive casting. So this casting we are learning for a primitive type of variable. So I'm giving name here as a primitive casting. So there are two types of casting as we discussed: implicit, implicit casting, and another one is explicit casting. Let's take an example of implicit casting first. Implicit casting is a way or is a casting where your value from one data type to another data type will be converted internally. You don't have to take any extra effort for that. Let's create one variable here of type byte. Now I wanted to convert this byte type of variable, or I wanted to assign this byte type of value to an integer, and that is possible. If I do this, then it will convert your a value into a integer b without writing any extra line of code. So Java always supports the implicit casting, and it does this implicit casting internally. In this case, we are converting or we are storing a byte type of value which is of size 8 by 8 bits into a 32 bit of data. So byte is a 8 bit of 8 bits, and integer is a 32 bit. So if you see here, the 8 bits of data we are storing inside a 32 bits. So there is no issues related to spaces or related to bits. But in the explicit casting, let's do the same thing in a reverse way. So I have a integer type of value, and I wanted to store this value into a byte. Here, Java will give us an compile time error even though this value can be stored inside a 8 bits of memory. This is an example of implicit casting, and here we are trying to convert a 32 bits of value into a 8 bits, and there can be a losses of the bits here in this conversion. And that's why Java doesn't support this kind of conversion internally, but you can do it by writing this extra code where we have to provide a type of data type in a bracket in which data type we want to convert this x value. So here we have mentioned this x is an integer which we want to convert into byte, and it will get stored or added inside a y variable. So this is an example of implicit and explicit casting. Let's print a value here. So I'm printing a value of a, value of b, value of x, and value of y. We'll print all four values here. They all having a same value which is 10, but there is a difference in the implementation because of casting. So this is an example of implicit casting and explicit casting. One more thing I would like to explain here is, let's say if I'm creating a variable here of type byte type of variable, let's name it as a n is equal to 10 or 100. Suppose if I wanted to add 1 into a n value, that means if I wanted to plus 1 the value of n value of this byte, then let me write this expression. So this expression looks very easy. We are just adding a 1 into a existing value of n, but it is giving us an error. And this is because of the data type or the result which gets generated will be in the form of integer. How results will be in integer? So the reason is, here we are providing a one value, and this one non-decimal numeric value, we do not specify any data type. So by default, Java consider this as a int data type. And when we are performing a operation between byte and int, the result will always be generated as per the large data type. So byte is a 8 bits, integer is a 32 bits. The result it will generate in the integer format. That means in the 32 bit of result it will generate. So to make this expression happen, we have to convert this into a byte. That means again we have to use an explicit casting here. We have to specify a data type. Only then this value can be converted and stored inside a n variable. So the takeaway from this discussion is, if you create or if you are using any of the numeric non-decimal value, by default Java provides a integer type of size or integer type of memory for that variable. If suppose if this variable is in the decimal format, then it will get a double data type memory, which is of 64 bits. If I print a value for n, then it will get a 101 as an output. So this is an output of the n. So this is about casting, and you will require a casting whenever you do such type of operations, this type of operations. The another thing which we discuss about a type of variables. So now we understood how to create a variables, what is a casting of the variables. You can use these variables into a mathematical expressions also. There you might require this type of conversions. There are different type of variables in the Java. Let's demonstrate that. I'm creating a new class here, and let's say it as a variable types. So variable types will be decided on the basis of the position where you create a variable. Let's say if I create a variable here a, and I'm assigning value to this as a 10, then I'm creating a variable here integer b, let's say it as a 20 value, and integer c, I'm giving value as 30. These are the three variables which we created. These variables, first of all, created at a different location. Out of these three, these two are created on the same location, but if you see a difference here is a static keyword. So first of all, a variable is called as a local variable. So the variable which is created inside a method, that variable is called as a local variable. The variable which is created outside a method and inside a class, that is called as instance variable. And the variable which is created inside a class and outside any method with a static keyword is called as static or class variable. So these are the three different types of variable we can create in Java. There is one concept called as default value. Like suppose if you don't provide any value for a B variable and C variable, then by default Java provides them a default value. But if you try to do a same thing for a local variable, it's not allowed. Local variable for now, it is not giving us an error because this local variable we are not using in any of the expression or for displaying out results. Suppose if I try to print a value of a variable, if I use this variable for printing a value, then we'll start getting an error here. And if you read that error, it says local variable may not have been initialized. So the rule here is local variable has to initialize before use. Either you can use that variable to print a value, or if you are using that variable in any expression, you have to make sure that this variable will be in or has to initialize before you are using it in any of the expressions or printing value. But if I try to print a value of C, here we cannot use a B variable because B variable is an instance variable. And to access this instance variable within a static method, you will require an object. We'll discuss about object creation and all of these things into uh, next session. For now, let me try to print a value of C. And if you see here, even though we are not initializing a C variable, we are not getting any error. Here, it is printing a value, or we are able to print a value. What values it will print, we'll see after execution of this program. Let me change the value of this. Let's say a value, I'm making it as a 10. And suppose if I'm running this program, then you can see the a value is 10 here and the c value is 0. So this variable has been initialized with the default value, and the default value for a byte short int long is 0. Suppose if I created a double type of variable here, then it will print a 0.0 as an output. So C value is 0.0 because for float and double, the default value will be 0.0. If I'm making it as a Boolean, for a Boolean, the default value is false. So here we are getting a false as an output. And suppose if I make it as a char, then for character, the default value is 0. And for 0, it will print some character. So it is printing a space here, but it is a default value of the character. Slash u 4 times 0 is the default value of the character. So this is how you can create a variable of different type, and for a different type of variable, their memory allocation will also be differ. We'll discuss about memory allocations of this different type of variable in later in the sessions. This is about a variable and their practical implementation. In the next session, we'll discuss about a control flow statement. Thank you very much for being here. We'll continue in the next session.